you can always come back to it. I think someone was asking about like changing the numbers for the input output. Really, the formula to follow is, and I'll draw it out, and that should help.
I actually had a question about that. It was on your practice test.
Yeah.
So if you change the 150 to 75 and then changed the 40 to a 30, 40 mLs to 30 ml, and the output was 4 hours per 200 mLs, I was not able to get the answer. I could do that one with that formula. That one was easy, but for some reason I couldn't understand the answer to the practice one.
Okay, so let me see here. So you said repeat the numbers, please.
Okay, for every 75 ml of urine output, replace with 30 mLs every 4 hours. If the output for the last 4 hours is 200 mLs, the fluid replacement volume would be how many mLs?
Okay. So let me. All right. So the way I would set up these types of questions is I always start off with what is my actual output. Then I would divide that by my potential output, or my potential output, which is the 75, and then multiply by the replacement volume. And unless the key was wrong, which happens, 200 times 30 divided by 75 will give you a fluid replacement volume of 80 milliliters. Did that help at all?
I guess I do it with the dosage, or like the mLs at the top like you did, but I put the ml, the 30 ml at the bottom to cross.
Did you do this? Did you do
I put the 200 over top and 75 at the bottom, and then I did a 1/30. That's
okay.
what I.
Yeah, you don't want to do a 1/30. This is like, these volume ins and outs don't really work the same way as the traditional questions that you guys are used to answering. So if I was going to do it like this is my actual output, this is my potential output, this is my actual replacement, and then I'm looking for this, then you would cross multiply. And you can set it up like this if you wanted to. The other thing is, I would say you might run into an issue with this just because your proportions might be out. I would say, for me, a better setup, if you're going to do like a ratio setup, would be something like this. But this is the potential side. And then my actual would be, I guess it still works out the same. So my actual output was 200, but my we're trying to calculate the actual input. And what you would do is you would figure out how many times does 75 go into 200. And so that number is not going to be exactly equal, but 200 divided by 75 gives me like 2.7. And if I multiply 30 times 2.7, I'm actually going to get 81 in that instance, which is close enough as far as that's concerned. But what I recommend is following this formula.
How did you do that one that you're pointing at again? You did the
Sure.
200 times.
So what this is the formula looks like, let me just, I'll write it down here. The formula for this looks like this. I'm going to take the actual output, so what the patient actually urinated out, over the potential output, which is for every however many milliliters lost times the replacement volume. So here would be 200 over 75 times 30, which is what I wrote up here. 200.
You would do 200 divided by 75, and then that answer times 30.
You got it.
Okay, perfect. Thank you.
Welcome. Yeah. I would just say just practice those types of questions. I know sometimes they're a little bit challenging, like, because they're not the usual questions. And I don't even know if you'll see that question, but it's in the practice. So and I guess it was on the
Yeah, I
practice
just
set.
didn't want to think. I didn't want to think it was going to be as easy as the regular number 6. So I thought I would change it up with the practice one.
Sure. No, I think that's good. It's a good challenge. That way you can kind of see, you know, the thing you did different, like you told me you did 1 over 30. Don't do that. Just multiply by 30 and you should be good.
Yeah, that makes more sense now that you explained it again.
All right, so number 8 says that we have a dopamine infusion at 5 micrograms per kilogram per minute for a patient weighing 70 kilograms. Dopamine available is 400 milligrams per 250 ml. At what rate should the nurse begin the infusion? So first and foremost, you need to know when we're talking about infusions, unless there's a drop factor given, then the infusion rate we're looking for would be milliliters per hour, okay? So that'll help out because we're going to have to do some converting. So what I'm going to do is I'm just going to write down a couple of the pieces of information that I need. Patient weighs 70 kilograms. The infusion is supposed to begin at 5 micrograms kilogram per minute. And so I'm going to take 70 times 5. And I'm going to get 350 micrograms per minute. Now, the second part of this question says that the available strength, and I'm guessing this is for an IV solution, is 400 milligrams per 250 ml. So I have micrograms, but then I have milligrams in my in there to make a conversion to. So I'm going to need to convert micrograms to milligrams or milligrams to micrograms. What I'm going to recommend before you even do that is go ahead and just convert minutes to hours just to kind of get this out of the way. It'll also make that number nice and big. And it's one less thing you have to do later on. I don't want micrograms, I want milligrams. In order to convert micrograms to milligrams, I'm just going to divide by 1,000, or I can move my decimal point over 3 places. Either way, we're going to come up with 21 milligrams per hour as our answer. And if you need to see that, just a couple ways you can do this. If you're going to do dimensional analysis, that there are 1,000 micrograms in 1 milligram. You could also move the decimal point, like I said, over 1, 2, 3 places. So there's a couple different ways in which you can set that problem up to get to your answer. Now that I have the 21 milligrams per hour, I'm going to convert. I don't want milligrams per hour. I want milliliters per hour. So I know I want milliliters on the top. I know I want to get rid of milligrams. And then my available tells me 400 milligrams. And then it tells me 250 ml. Or I do any kind of math, I can make sure I'm good. The only units I have remaining are milliliters per hour. So 21 times 250 divided by 400 give me 13.125 milliliters per hour. And then you would round that to 13.1 milliliters per hour. But I know a couple people asked about number 8. Even someone emailed me. I haven't got a chance to respond via email, but if you're on here, I'll still respond to you if you emailed me. Help you answer question number 8. If you have any additional questions, let me know before I move on.
So do we have to round? Because it left it as the answer as 13.125.
Yes.
Okay.
Round to the nearest 10th. Yeah, I'm not sure why it was left unrounded in the key, but what I would say is when you're writing this out, put both answers. I mean, write out what, your full answer and then round it. But yeah, you should round your answers to the nearest 10th. I know you guys are kind of in the, you're just getting out of pediatrics mode where, you're not rounding or, it's kind of frowned upon to round, but at some point you have to round in order to display your numbers within reason. So yeah, you should be rounding this though. All right, so I'll do 15. I'm just doing them in order, so I know these got put in a couple ways. So 15. Okay, so the trick with this one is just knowing to so number 15 says calculate the number of hours and minutes if you have 420 cc's of sodium chloride running at an infusion of 120 cc's per hour. So there's a couple different ways that you can do this. First thing is, first of all, is it going to be an equal number? And so you can just plug it into your calculator real quick. You say 420 divided by 120, and then are the numbers even? When you do that, you get 3.5. So you know that it's going to run for 3 hours and 30 minutes. But just so you can see what that looks like. So 420 cc's. And we're going to convert the cc's hours. If and I'll give you another example of this just to kind of see if we can change what this might look like if it got a little bit confusing. If it's 120 cc's per hour, and like I said, I just took 420 divided by 120 and I get 3.5. And then the way you would represent that answer is 3 hours, 30 minutes. I think is pretty straightforward. If, like, let's say it was 400 cc's, let me just see. I want to try and get something that. If it was 400 cc's, still at 120 cc's per hour, you're going to get something that looks like 3.333 repeating. How are you going to figure out how many minutes that is? So if you ever get it, and I don't think you'll ever see anything like this, but it's a good, kind of strategy if you do. I would say, don't, obviously, you're not going to say 3 hours and 0.333 minutes. You can multiply that 0.333 by 60. Alternatively, you can also get a good rough estimate by, instead of saying hours, just convert this to minutes. And I'll show you what I'm going to do here in just a second. So you already know it's 3 hours. You're just trying to figure out this 333. So take 0.333 and multiply that by 60, you get 19.98, which would be about 20 minutes. If you do it this way, 400 times 60 divided by 120, you get a total of 200 minutes. So how could I convert that? So you already know that 60 minutes is an hour, then 120 minutes is 2 hours, 180 minutes is 3 hours, and then 20 minutes. And what I was getting at is I just gave you 2 ways to kind of figure this out. You can take the decimal, multiply it by 60, and that'll give you the minutes. Or you can convert the hour to minutes and then just kind of break it down from here. You probably know how to do it from here because you're like, okay, 90 minutes I know is 1 hour, 30 minutes. If it was, 75 minutes, you could say, okay, that's 1 hour, 15 minutes. You could break that down and you can kind of figure that out. But I was just kind of giving you some additional tips just in case you see something like this, but most likely you're going to see it where it's going to end in like 3, 3.5, 3.25, 3.75. And just remember, quarter hours are 15 minutes and 40, and then 45 minutes for a quarter, and then 75. It's not 25 and 75. And 22, 23, and 24. Okay, so 22, 23, and 24 are all kind of going to help you out with the heparin protocol, which none of you asked about, but I'm hoping that you have a good idea with that. But basically, the heparin protocol, like when you're calculating the infusion rate, you have to do what you're going to do in 22, 23, and 24, which is convert units per hour to milliliters per hour. So let's do some of that. All right. So for 22, it says the physician orders heparin IV to infuse at 750 units per hour. The solution strength is 25,000 units of heparin in a 1 liter bag of dextrose 5% water. And we want to know the flow rate in milliliters per hour. So I came up with this earlier today. As a strategy, I'm going to recommend that you start with the units per hour that they give you. 750 units per hour. I don't want units per hour. I want milliliters per hour. We know that because it says to calculate milliliters per hour. So since you know that, you want milliliters on top, you don't, and you want to get rid of units. So before you do anything with figuring out what numbers go where, if you do dimensional analysis, this will at least help you strategize or give you some sort of strategy of where things go. If I can tell you anything, just make sure hours are in the denominator and make sure milliliters are in the numerator. As long as you got that, you should be fine. And then if you don't like the words numerator and denominator, make sure hours are in the bottom and milliliters are in the top, just like it asks in the question to calculate the flow rate in milliliters per hour. Then you just look at your question and it says your solution is available 25,000 units of heparin in a 1,000 milliliter bag. So that tells you what you're using, 25,000 units of heparin in a 1,000 milliliter IV solution. So this is very similar to the heparin protocol, but they use 250 milliliters per 25,000 units. Then one of the reasons why I like dimensional analysis is I know I've set it up right even before I've done anything. Then I'm just going to take that 750 times 1,000 divided by 25,000. And I'm going to get 30 milliliters per hour. If you got something like 30.4545 milliliters per hour, round it to the nearest tenth.
So if you don't do dimensional analysis, because I avoid that like as much as possible, you could just basically just take the actual, which is 750, divided by what's on hand, which is the 25,000 multiplied by the volume. You just need to know to change 1 liter to 1,000. You can do it.
You got it. That
Okay.
should work fine. I would just say just practice it, because that's one of the things that like you can absolutely do, but sometimes people will choose the wrong volume or they'll use the wrong units. So as long as if you start with the rate, then you should be able to follow the strategy you just said, and that should work out because you're doing the exact same thing I'm doing.
Okay.
Just make sure you're using the correct units as you're available, which is what's in the IV. So for the, and I'll even set it up the way you just said it. So for number 23, doing it so my order is a 1,250 units per hour, or I can't remember what you said, but the starting point. Always start with the infusion rate. I used this example earlier with the 220, 230 class. I said, if you're in Canada and everything's in kilometers per hour, you might want to know what that is in miles per hour. And so you have to do a little bit of a conversion, but you're always going to start with miles per hour and then convert it to kilometers per hour. And you're like, no, I'm just going to look at the numbers that are already on my dash, or I'll push a button, or I just won't drive. But all right, then I would divide by my available, which is again 25,000 units. And then I would multiply by what my IV solution is, which is the 500 milliliters. Is this how you would set that up?
That's how I did it exactly.
Yep. Yeah, as long as you're setting it up just like this, you're doing it right.
Because at the end of the question, like this is what I'm doing, and let me know if I'm wrong, but like it says, what is the flow rate in milliliters per hour? So you're looking for mLs per hour.
Mm-hmm. No, you're good. Yeah, you're doing it right. That's what I was saying. Like, as long as you're not mixing these up like every other time you do it, you're setting this. What is written here is exactly what's written here. You just don't like the way this looks. So I'm going to take the 1,250 times the 500 divided by the 25,000, and I'm going to get 25 milliliters per hour. Then 24 is the same thing. It's just now we're using insulin instead of heparin. And I'll set it up exactly like this. 15 units per hour. The units I have available is 100. The volume I have available is 500. The 15 times 500 divided by 100, and I'll get 75 mil per hour. Good. Oh, now you guys want to see number 25. Okay. Any questions? 22, 23, 24? And we'll go ahead and do 25. So you saw this for 25, you saw the heparin protocol for the first time last semester. Let me just in here so I can just show you a few things just as a reminder. So a couple things about the bolus and the heparin protocol. A lot of the stuff's repeated. The important things you need to know is you first need to know patient's weight. You need to know that you're going to convert that patient's weight from pounds to kilograms. You're pretty much going to ignore 3 through 9 because that has nothing to do with when you are trying to answer the math part of this. So I'm going to highlight the important areas. Step 2, step 10. Okay. And then the patient's weight. Those are the important parts of the protocol. These things, for math purposes, are not really going to help us out with answering the protocol. Okay. Then I'm going to look at the questions. Now, on your test, you're going to have either these two or those two questions. So you're going to have parts A and B as 2 questions, or parts C1, C2 as 2 questions. 2 questions or 2 parts to 1 question. If you miss both, you only missed 1. If you miss 1, though, you still missed 1. So we're gonna show you how to get it right both times. Okay, so you've probably seen me work through this question a couple of times if you've checked out the YouTube channel or if you've gone through this a couple of times. So you should already know that the patient's weight at 110 pounds is in kilograms. You just divide by 2.2 and it's 50 kilograms. If I were going to be doing this with, or the only thing that can really change with this and what you'll see on your test is they'll just use a different weight for the patient. So they'll use a 120-pound patient. They'll use a 96-pound patient. They'll use a 245-pound patient. You just need to make sure you convert pounds to kilograms. And if you get like a repeating decimal, just round to the nearest 10th before you do your calculations. So I have a 50-kilogram patient. First thing that the question 25 asks me is to calculate the bolus dosage strength. And so what I'm going to do is, looking at the protocol, it tells me to initially bolus with 80 units per kilogram. You're just going to multiply by the patient's weight by 80, and you'll get 4,000 units. If I don't want units, I want milliliters, because the question says how many milliliters to administer for the bolus. I need a way to convert units to milliliters. So I need to look at the bolus dosage strength. The bolus dosage strength tells me it's 1,000 units per milliliter. So 1,000 units per milliliter. And if you're doing this, the ordered over half, just 4,000 divided by 1,000 times 1 will give you that answer. And that answer is 4 milliliters. Any question where I'm getting this information from? Just in case, as a reminder, going back to the pack or to the heparin protocol, you see where it says bolus with 80 units per kilogram down here. And then it tells me the bolus dosage strength is 1,000 units per milliliter. So that's where I'm getting that information from. I didn't make it up. I didn't guess. I just looked at it from at the heparin protocol. All right. Next thing. I need to know what to set the infusion rate to. So I'm going to take the same patient, same weight, 50 kilograms. And it tells me to start an infusion at 18 units per kilogram per hour. I'm just going to multiply the patient's weight times 18, and I'll get 900 units per hour. And again, this is where you could set this up exactly like we were setting up the other ones, where you can do the 900 units per hour. And then you look at the protocol. Protocol says that we have heparin 25,000 units and 250 milliliters, half normal saline. So if you wanted to, you could just take the 900 divided by 25,000, multiply by 250, and you're going to be doing the exact same thing that I'm doing here with the dimensional analysis. So 900 units. $25,000 units, 250 ml. Multiply 900 by 250 divided by 25,000, and you will get 9 milliliters per hour. Then, so we're done with that. Then we have C1 and C2. C1 says we look at the APTT. It says it's 43 seconds. Actually, let me just double check and see if this is the same as the other ones. Yeah, 43 seconds. And then you look at the protocol and you say, okay, what do I do if the APTT is 43 seconds? Well, you jump down to step 12 and it tells you to rebolus with 40 units per kilogram and then to increase the rate by 2 units per kilogram per hour. Now, on the actual test, this might be the only thing you're doing a calculation for. So the rebolus may not mean anything, but because you know 40 units is half of 80 units, you could just safely assume that it will be a 2 milliliter rebolus. Okay. But I'll show you how to do the math. I'm going to do basically the exact same thing I did in A. But for B, I need to make sure that I increase the rate by 2 units per kilogram per hour, meaning that we started at 18 units per kilogram per hour, but now I'm going to change that to 20 units per kilogram per hour. All right. So same patient, same weight. This time we're going to rebolus with 40 units per kilogram, which will give me 2,000 units to administer. I don't want to administer units. I need to administer milliliters. So I'm going to account for the bolus dosage strength, which tells me there are 1,000 units per milliliter. Again, if you're doing the order of a half, you can just do the 2,000 units over the 1,000 units times 1 milliliter. We're going to get the same answer as of 2 milliliters. And then for part 2 of C, you're going to get, again, same patient weight. It says to increase by 2 units per kilogram per hour. If our initial was 18 units per kilogram per hour, then we're going to increase it to 20 units. Will give me 1,000 units per hour. I'm just going to write this a little bit differently. I'm going to write it like we were doing earlier. And then I'm going to look at my available. That'll give me 10 milliliters per hour.
Does that say 25,000 units?
Yes, it's the same as this, 25,000. And then I got that information from step 2 of the protocol where it says heparin 25,000 units, 250 ml. That's our available for the infusion. And then the 1,000 units per milliliters are available for the bolus. Really, the only thing that would change for the for this question would be the patient's weight. So and then your answers might, if the patient's weight is in is a to the 10th, like let's say the patient's weight ends up being like 90.5 kilograms, then when you do your calculations, you might end up with something like 4.8 milliliters as a bolus dosage strength, or 11.2 milliliters per hour as your infusion rate. Round to the nearest 10th, because we're talking about milliliters per hour. If there were drops involved, then you could say, round to the nearest whole drop. But for milliliters per hour and for milliliters, you can round to the nearest 10th.
Can I see your paper one more time?
Sure. I never know what you can see versus what's being displayed. I don't even know if you could just click on it.
Does that say equals 10?
Equals 10 milliliters per hour. Yeah.
Okay, thank you.
You're welcome. All right, and then I had a question for 16 and 17. So let me or 70. I can show them to you both because they're both pretty quick to do. Let me just share this. So for like 16, and I'll just use the annotation tools. For number 16, in order to calculate drop rate, remember I need 2 pieces of information. I need the flow rate and I need the drop factor. So all I'm going to do is I'm going to take the 120 milliliters per hour times 15 and then convert hours to minutes. The shortcut is 120 milliliters over 60 minutes times 15. So 2 times 15. So the answer for this would just be 30. Drops per minute. And if you're wondering about, well, what about the 500 milliliters? Well, what about it? That just tells us how much is there. I need to know the flow rate. If it said 500 milliliters infusing over 2 hours, then I would have to do a little bit of calculation to calculate the infusion rate. But this tells me the infusion rate already is 120 milliliters per hour. So I just use what it gives me. An example of what I was just saying is like for this, it says a physician orders 180 milliliter unit packet of red blood cells to be received within 1 hour. So my flow rate for this is 180 milliliters per hour, because I have volume and I have time, times 10. I'm going to tell you to do the same thing with this. 1 hour is the same thing as 60 minutes. So 180 over 60 is 3 times 10, and my answer is actually the same. So for both 16 and 17, the answer is the same.
Got it. Thank you. Yeah, sometimes that 516 just threw me off, I think, a little.
Sure. No, and that's why it's there. It's there as a distractor. And now you know. Yeah, for drop rates, you just need to know flow rate and drop factor. Nothing else really matters. It doesn't matter if it's a 400 milligram solution. If there's 500 milliliters of it, the only reason you would need to know the total volume is if it also gave you a time and it didn't give you the flow rate. So that's good. You asked a good question.
Thank you.
Okay, are there any other questions? I think we kind of covered most things here that I think you'll see.
No, thank you so much.
Yeah, you're welcome. So for 240, I will also be here this evening at 6:15 for you guys. And then on Thursday, again at 2:30, and then again at 6:15. So if you have any questions between now and then, just know you can hop on and ask away. You're welcome.
Thank you.
You're welcome.
Thanks so much.
You're welcome.
I know you have a little bit more time, and I'm sorry to ask another question. But could you just go over number 11 really quickly? I know how to do it. I just want to, make sure.
Okay. Okay, yeah, so this is another one of those examples where there's extra information that you don't need to know in order to answer the question. So there, you have 200 milligrams IV, available as 100 milligrams. The label reads 30 milligrams per milliliters, how many milliliters? So you want to look at, okay, the order is 200 milligrams. The available, it's almost like they're giving you two pieces of information, 100 milligrams IV, but then it also tells you the concentration. These are the two pieces of information that you need in order to solve this question. You need to know the order and you need to know the available. And because it's an IV, you need the milliliters. So like, I can't just give this person, 200 over 100, which is one what? One capsule, one tablet, one IV. So I just take the 200 divided by 30. And I get 6.66666, and that's 6.7 milliliters.
Awesome, thank you.
Yeah, you're welcome. It's a good question. I always forget that some of these things that are on here that are kind of like, they're tricky and they're, supposed to be tricky to get you to think through them, but they can be challenging because there's like extra numbers there. So. Any other questions?